First one of these was a rate in, rate out question. So our W of t is our rate in, and our R of t is our rate out, that we're getting things removed. So part A says estimate R prime of 2. So for R prime of 2, that's going to be the slope of R at 2. So let's use slope at points around 2. And let's make sure we have units that give a point for putting units on this one. So if it says something like indicate units of measure or using correct units, make sure that you are doing that. Because that probably means that in order to get the point, you need the units. Or even in something like this, they'll give a point for you getting the units correct. For knowing that if the original function is in liters per hour, then derivative needs to be in liters per hour squared. Left Riemann sum. And left Riemann sum is going to use everything but the right endpoint. And that's going to be in liters. And I can show this in a little bit, but overestimate or underestimate for a Riemann sum, and you can test this out by drawing some pictures. Overestimate or underestimate for Riemann sums is determined by increasing and decreasing. So this is a left Riemann sum, and this function is decreasing. So if you draw the picture, you'll see that that's going to overestimate the actual curve. Part C. Using the answer from part B, we're going to find the total amount of water. If we want amount, right now we have the rate, so we're going to use an integral to get back to that rate. We're also going to use the initial condition that there were 50,000 liters in the tank. So we started with 50,000. Our rate in is W of t, so we're going to add that integral, and then we're going to subtract the rate out, which is what we found with the Riemann sum. So these are integrals that we are using because we are going from a rate back to an amount. And part D, is there a time t when the rate at which water is being pumped in is the same as the rate at which water is being removed? So in other words, it's asking, is there a time when W and R are equal? And this is an intermediate value theorem question. And so one way we can do this is we're going to talk through intermediate value theorem. We can tell that at 0, basically at 0, W is bigger than R, and at 8, at the endpoint, W is less than R. And so at some point, because our functions are continuous, that had to cross, and the rate in had to pass the rate out, which meant at some point they had to be the same in order to pass each other. So that's an intermediate value theorem question. Number 2 here gives you the velocity function. It gives you an initial position at t equals 4. Our position is at 2. So at t equals 4, is the particle speeding up or slowing down? Remember, speeding up or slowing down is determined by velocity and acceleration. You need to compare both of them. So on some people's, I've been seeing you talking about either one or the other. You need to compare and talk about both of them. So velocity is positive, acceleration is negative. So that means, since they have opposite signs, that means that our particle is slowing down. Next, you'll hear me say this pretty often here over the next couple weeks. Make sure you are explaining things in terms of the function that they are giving you. So they're giving me velocity. So when I explain my answers, I'm going to explain it in terms of velocity, and I'm going to be specific about saying that I'm talking about velocity. So when does the particle change direction? Well, that's when velocity changes sign. Because then we change from moving left to moving right, or from moving right to moving left. So that happens at this decimal in the calculator. So velocity changes from positive to negative at that point. So the particle is changing direction. It's changing from moving to the right to moving to the left. Position at 0. Here's the function for the position at 0. Right, we're using our initial condition of at 4, our position's at 2. So we're starting at 2. And then we want to know the integral from 4 to whatever point. So that when I plug in 4 here, I have the integral from 4 to 4, which cancels this out. And so we're just left with that starting position. Usually this starting, this lower bound of the integral here, usually it's 0 because it gives us our initial position at 0. But here it gave us our initial position at 4. So 4 is the lower bound there. If you wanted to switch these bounds, you would have to make the sign negative here. Either way, that's the integral you should get out of the calculator. So we need to then add the fact that we started at 2 and basically moved this far to the left to get our position there. And then total distance traveled. This should be free points. Total distance traveled is the integral from A to B of velocity, of the absolute value velocity. And so you just put that in the calculator and give out the answer. There's your total distance traveled. All right, as soon as I see this, this function, that g is the integral of f, I'm going to think about that in the other direction. And the first thing I write on this, a question like this, is that that means that g prime of x equals f of x. Like that's the first thing I write. So g is the integral of f means that the derivative of g is f. Right? Derivatives and integrals are opposites of each other. And so you want to say that in your explanations. When it talks about does g have a relative minimum, relative maximum, you should be talking about the graph of f, but you should also connect it to g so that they know that you understand why, if we're answering questions about g, why can we talk about f? Well, we can talk about f because f is the derivative of g. So you need to say that somewhere in these explanations. So now that we know that this is the graph of g prime, so we can say relative minimum, relative maximum are neither at 10. Well, since this is g prime, if it were a minimum or maximum, we would be looking for it to either change from negative to positive or from positive to negative. But at 10, it's 0, but it doesn't change sign. It's negative before, and then it stays negative after. So neither. And again, at some point, they're looking for you to say that g prime is f, and they give you a point if at some point in your explanations you talk about the fact that f is g prime. Point of inflection. Point of inflection is when the second derivative changes sign. So it would be when the first derivative basically has a maximum or a minimum. So in other words, this first derivative changes from increasing to decreasing, which means that the second derivative will change from positive to negative, which means that we'll have a point of inflection. So basically, you'll be looking for a maximum or minimum happening in the first derivative to look for points of inflection. So there's also a point of inflection at 0, at 2, at 4, at 8, and at 10. Absolute minimum and absolute maximum. Here are your steps. Anytime it asks for absolute minimum or absolute maximum. First off, look at the derivative. So you might have to take the derivative. Look at the derivative. Look for where it changes sign from negative to positive or from positive to negative. Write those points down. So you have those candidates, and then you have the candidates for the endpoints. Since it's asking for absolute minimum, absolute maximum, the endpoints are also possibilities for absolute min and max. So since I have the graph of the derivative in front of me, then I can really easily look and see where this is going to change signs. This is going to change signs at -2. It's going to change signs at +6. So we have those two candidates plus the endpoints. If you say that, you get a point. Then we need to talk about the endpoints as well. Now, to find the values, which is our next step, we're going to test what these values are. And since we're looking for both absolute minimum and absolute maximum, those are 4 candidates. Now we need to see which one's the smallest, which one's the biggest. And to do that, we're going to use our integral. And so that means we're going to have to find some areas. If we want the integral on this graph, we're going to have to find some areas. So we find some areas. There's our points. The smallest one is at -2. The largest one is at 6. So there is your absolute minimum, absolute maximum. Find where g of x is less than or equal to 0. So we want to know where the original function is less than or equal to 0. Well, first off, this table of values should give you a good idea. And you should know that since it's the integral from 2 to x, the integral from 2 to 2 is going to be 0. So at 2, it's going to hit 0. And then you can determine your values and figure out that starting at 10, it dips down below 0 again and keeps decreasing out to 12. All right, slope field. People are usually good at their slope fields. This is what the slope field should look like. When y is 0, the slope is 0. dy dx is 0. And then you can plug those other points in. Then it says, write the equation of the line tangent to the graph. So we have the point 2, 3. So we need the slope at that point in order to get our tangent line. Because remember, that's going to be y minus our y coordinate equals the slope times x minus the x coordinate. So we have our y coordinate is 3. We have our x coordinate is 2. We need our slope. And what's going to help us do that? The derivative, dy dx. So we're going to find dy dx when x is 2 and y is 3, which is 9, and that goes in for our slope. Then it asks us to use that line to estimate f of 2.1. So we're going to take 2.1, put it in for x, and see what y is. And finally, part C, when it says the phrasing, find the particular solution to the differential equation, that should click in your head, and you should be able to recognize that immediately as a separation of variables question. So there is your separation of variables process. separate out the variables. Antiderivative uses natural log. Then they plugged in and solved for C. And went from there. So on number 5, average value of the radius. Well, here's my radius function. It's given to me. And so if I want average value of the function in front of me, average value of a function is 1 over b minus a times the integral from a to b. So now you need to show out a little bit of work, do a little bit of antiderivative since this is non-calculator, and figure out what that is. Average value of a function, 1 over b minus a times the integral from a to b. Part B, find the volume. So, you could almost think of this in a similar way that we think about like cross sections or our discs or washers. Because all we have to do to find the volume, to find the amount of space in here, is that this is made up of a bunch of circles. You can think of this as a bunch of different circles stacked on top of each other. And so basically what we're doing is we're accumulating each of those circles, and like if I stacked them on top of each other and accumulated and added them together, then I would be able to figure out what the volume is. So first of all, to find the area of that circle, area of the circle is pi r squared. And we know what r is. R is 1/20th times 3 plus h squared. So that is our area of this circle in terms of the height. And so we're basically accumulating all of these from that height. And so how many of these are going? It's starting down at 0 and going up to our height of 10. So to get from the area to volume to accumulate up all of those circles, that's what the integral is going to let us do. So we're basically going to take the integral from 0 to 10 of this area formula for the circle. And then there's the details for doing the antiderivative and plugging in 10 minus plugging in 0. Answer. By the way, this is one of the more complicated things that I've ever seen them ask you to do on a non-calculator question. But the good news is that since you're plugging in 10, it's not too difficult to take to know what 10 to the third is or 10 to the fifth. And most of the points come from, do you know that you're using the pi r squared? Can you take the antiderivative? And that should be pretty straightforward. And then the last point is for the answer. Same thing on part A. All right, and now part C is your related rates question. And so we're going to use this same formula here for R, and the radius is decreasing, so this tells me dr dt is -1/5, and it is asking for dh dt. So we're going to use that function for R that's out in front of us and plug in those values. We're going to plug in 3 for h. We're going to plug in the -1/5 for dr dt and solve for dh dt. Equation of the tangent line. Again, we need to figure out the y value at 3. We need to figure out the derivative at 3. And we're going to put those into equation of tangent line stuff. And this really gets your knowledge of derivative rules going here. So part A, if I take the derivative of k, then that's a chain rule. F prime of g of 3 times g prime of 3. Plug all that in. We're using the table to figure out what these values are, and we get out 10 for the slope. And k of 3, that's f of g of 3, so g of 3 is 6, so f of 6 is 4. So those are the values we put in our equation of the tangent line. Find h prime of 1. Since h is g over f, that's a quotient rule. Low d high minus high d low over the square of what's below. Plug in 1, -3/2. And again, if the calculation stuff down there looks intimidating to you, remember that 2 of the 3 points are for just making sure that you know the quotient rule. Integral from 1 to 3, you can do this as a u substitution if you want, since there's a 2x inside the other function. But you should know that the antiderivative there is of the second derivative is going to be the first derivative. And then I need a 1/2 to undo the chain rule that would happen with this 2x inside of the other function. And then plug in 3 minus plug in 1, since there's a 2x inside of here. When I plug in 3, that's going to total be f prime of 6, and this is going to total be f prime of 2. And then get out your value.